Hello guys, you're welcome to my channel. Now right here in this video, I want us to integrate or to learn how to integrate x times e to the x using integration by parts. And now here we go, right? Integration by parts, we need to know what we want to differentiate and what we want to integrate, okay, in order to have a particular substitution for them. Or now knowing that the formula for integration by parts goes this way: the integral of u dv is equal to uv, the product of the two functions, could be functions of x depending on the variable of integration, and minus the integral of v du. Now you look between x and e to the power x, which one is most easier to differentiate? Well, x is easier to differentiate. You know the derivative of x with respect to x. Very nice. And you also know the derivative of e to the x with respect to x. Also very nice. Now, how about integration? Which one is also very easy to integrate? The both of them are quite easier to integrate, alright? Great. But you know that if we differentiate x, we're going to actually get a constant, and that will make our work more simpler. So, to differentiate x, it simply means that x should take the place of u where we differentiate. So I will say let u be equal to x. So to differentiate that, we say that the derivative of u with respect to x is going to become 1. Alright? And from there we can just have that du is equal to dx by cross multiplication, just like that. Now, since our u is equal to x, which other component do we need? We need dv. That simply means that dv will take the other part. dv will now become the remaining part, that is e to the x dx. It's not just dv equals to dx, rather the other function with the variable of integration. So we go like that, and to get v, we have to do some integration of dv. So integrating dv, we're going to get the integral of e to the x dx. Now integrating just a variable of integration, so the integral of dv, okay, where there is just 1, is just going to give us v. Hope you know that. And the integral of e to the x with respect to x, you know, e to the x is just that function that doesn't change, okay, it remains the same. So we're just going to have e to the x. So since dv was e to the x dx, then v is just e to the x. So we can just take that and substitute to the right hand side, and we have what we want. So we'll be using the formula to guide us. So I'm not going to clean the formula. Okay, let's just continue with our work. So we have this. Now what is u times v? Well, our u is already here. So what's our v? This. So we need to multiply that out. So from here we continue. We have u times v is going to be x times v e to the x minus the integral of v here is just e to the x. Write that out. And the u here is what? Is dx. No, sorry, the u is here, so that's just dx. And now we have x e to the x minus the integral of e to the x dx is just what? That is just the same thing, like I said. E to the x, the only function where the derivative and the integration are equal. Well, it may not be the only function, but it is one of those functions if they are more than that, if they are more than 1. So we have the integral of e to the x, just e to the x. And because we are integrating an indefinite integral, we just have to add a plus c for them, alright? So here we're just going to have, know where this is common. We are done already, but we can just do some factoring. We have e to the x, and we have here to be x minus 1 plus c. Or we take this back, like just x minus 1 e to the x plus c. Well, from here lies the solution, alright? Great. Do we still have a little time left?